The population of Nigeria was about 186 million in 2016, and the exponential growth rate was 2.6% per year. Part A. Write an exponential function describing the population of Nigeria. We have an exponential growth model of P of t is equal to P naught times e to the kt. Well, we're given that the original population was 186 million, so I can start with P of t equals 186 for P naught, and then we have e to the k times t. Well, k is the growth rate, written as a decimal. So since the growth rate was 2.6% per year, we'll put 0.026 in for k and multiply that by t. This gives us the model P of t is equal to 186 e to the 0.026 t, where p is millions of people, and t is the number of years after 2016. Part B. What will the population be in 2020, in 2050? Well, since our model has t being the number of years after 2016, then the year 2020 has a t value of 4, and the year 2050 has a t value then of 34. So we need to find p at 4 and p at 34. So p at 4 will be 186 e to the 0.026 times 4. Using a calculator, this gives us approximately 206.386. And to find p of 34, we have 186 times e to the 0.026 times 34. Typing this in a calculator, we get approximately 450.225. This tells us that in the year 2020, the population will be about 206 million. And in the year 2050, the population will be about 450 million. Part C. When will the population reach 500 million? Well, this time we're given P of t, which is 500. Using the model we created, we have 500 is equal to 186 e to the 0.026 t. Now we need to solve for t. First, we need to divide both sides by 186. This gives us 500 over 186 is equal to e to the 0.026t. Next, to get t out of the exponent, we'll take the natural log of both sides. So we have the natural log of 500 over 186 is equal to the natural log of e to the 0.026t. On the left, we still have the natural log of 500 over 186. I'm not going to put these values in my calculator until t is isolated. On the right-hand side, taking the natural log of the exponential base e cancels each other, leaving us with just 0.026t. So the last step, then, is to divide both sides by 0.026, giving us the natural log of 500 over 186 all over 0.026 is equal to t. Now we'll type this in our calculator and get approximately 38.033. Recall that t is the number of years after 2016, so they want to know when or in which year. So we'll have to take 2016 and add 38 years to it. That gives us the year 2054. Therefore, the population will reach 500 million in 2054. Finally, Part D. What is the doubling time? Well, the doubling time would mean that 186 million will double, or become 372. So we'll let P of t be 372 million. So 372 is equal to 186 e to the 0.026t. If we divide both sides by 186, we see that 2 is equal to e to the 0.026t. Or in other words, every 1 became 2, which means it will double. So solving this for t, once again, we need to take the natural log of both sides. This gives us the natural log of 2 is equal to the natural log of e to the 0.026t. Simplifying, we have natural log of 2 is equal to 0.026t. And finally, dividing both sides by 0.026 gives us the natural log of 2 over 0.026 is equal to t. Typing this in our calculator, we get approximately 26.66. So this time they're not asking for which year, they're just asking what is the time to double. Therefore, the doubling time is approximately 26.7 years.